Hello, I'm Andy Briggs and welcome to the amazing Astronomical Alphabet, a weekly programme in which my Astro Radio co-presenter Daz and I will be talking about anything astronomy related which begins with the week's letter of the alphabet. We'll each choose some things to talk about which are in some way related to the universe, but neither of us will know what the other has chosen. We will then reveal facts about them which are weird, strange, bizarre or simply interesting. So, hello Daz, how are you?
I'm fine, thank you very much. I've been really looking forward to this.
Yeah.
I've got all my little bits of paper around me with all my contributions to this, and I'm hoping you'll find some of them interesting. And I'm certainly looking forward to hearing your selection. So it should be great.
I'm really looking forward to what we can learn from each other, and hopefully the listeners will love it too. So there we are.
Fantastic.
So then, first week. Logically and consequentially, the letter for this week is the letter A. So, Daz, you can start with this one. A is for what?
The Arecibo message.
Oh, yes.
That one in there. Yeah. Basically, what it is I won't go into too much detail as regards the science behind it, but it was the child of Frank Drake, the founder of SETI. He founded SETI in 1960,
and
which is the search.
Author of the famous equation, of course.
Exactly. The equation, which was a guesstimate of how many planets in our solar system could contain life.
Or the galaxy.
That's the one.
Yeah.
Oh, the galaxy, sorry. What did I say? Yeah.
I think we know of one in the solar system, at least.
Yeah. Oh, yeah. Sorry, did I say solar system? Yeah. I do apologise. Yeah. Well, it's not intelligent life, though, is it? Anyway. Yeah. So he founded SETI in 1960, which was the search for extraterrestrial intelligence. And basically what they've been doing ever since then is they've been listening for signals from ET, basically. They've been trying to detect them. But this time, in 1974, the Arecibo dish in Puerto Rico, which is a big radio telescope, was updated. And what they did is they, as well as updating in all the electronics and things like that, they actually added a transmitter. Right. So it went from just being a receiver to a receiver and a transmitter. And it was because they added this transmitter, it became a great near-Earth asteroid catching telescope. And they were able to use it because it really precisely predicted their the direction they were going, and they were able to use the radar to map what they looked like.
I see.
So that's basically what the whole idea was. But of course, back in 1974, they were going to switch the thing on, and they thought, well, what can we do to celebrate this? We've already got a big party planned. And someone came up with an idea of actually transmitting a message out into space. Because it transmits now, let's transmit something. So that's what they did. And it was more of a gimmick. It wasn't designed to actually try and contact intelligent life or other civilizations. It was just a gimmick. It was a proof of concept that they could do it. So we're going to actually give it a go.
So we have a nice bit of PR for Arecibo as well.
Yeah, exactly. And it was so they basically what they did. They chose a target, and they chose the Great Globular Cluster in Hercules, M13.
M13, indeed.
Yes, and so that's what they chose. Well, and it's a long way off anyway. The message was sent at the celebration party, but it was only broadcast for about 2 minutes.
Right.
So after 2 minutes, everybody went back to the canapes and all the everything else. Back to the wine.
Thinking about the electricity bill.
Yeah, exactly. Yeah. Well, they weren't paying for it, so no. Yeah, they were putting 50p's in the meter as they were doing it.
Do we know why they chose M13 to send the signal to, or was it just?
I just think it was just plucked out of the hat because, as we said before, or we've mentioned before in the past, M13 is a globular cluster that's full of ancient stars. They're very, very old. And it's not a very good target for possibly finding life. For the simple reason is because they are ancient stars and they're all quite large stars. They haven't gone through their process. They haven't gone through their life cycles. They haven't done their supernova bit or their planetary nebula bit where they puff off the gas. So they haven't seeded the in between the stars. They haven't seeded the gaps in between with the building blocks or the elements to make planets that could host life.
So
it's not a very good target.
With M13, we're talking about stars that are, as old as the galaxy.
Yes, near as damn it.
These are very metal poor stars. And for our listeners' benefit, in case you don't know, when astronomers say metal poor, any star that has got elements heavier than hydrogen or helium, and I think lithium, has got metals. So anything heavier than those elements is a metal, according to science. So metal poor stars are stars that have not, as Daz said, gone through the business of accumulating or accreting material from an older generation of stars. So in fact, they are very primitive stars indeed, and not at all where you might expect to find planets, in fact.
Exactly. So the chance of life being there is very, very small.
But as you said, Daz, it was just a gimmick.
That's right. It was just a gimmick.
So can you give us a rough idea of what was in the message? What did they say?
Well, basically what they said, because they sent the message twice. Again, it was only for 2 minutes. So basically, ET's got to be looking our way to catch these two short bursts of things and all that. It was basically a message written in binary code, which is basically a series of ones and noughts. Like you use on a computer code and stuff like that. And when it's decoded, it produced a pixelated image. And there's a lot more science into it. They chose frequencies and things like that, which all went into something that they reckon. A lot of assumptions were made that if ET could pick up the signal, they would know what to do with it. So it was all assumptions.
If I remember rightly, didn't they have a representation of the 21 centimeter neutral hydrogen line on the basis that because hydrogen is the most plentiful element in the universe, any extraterrestrials would know about it. So we could talk in the language of hydrogen, if you like.
That's right. There was basically the thing. There was a lot of assumptions made that these aliens would actually be so similar to us and how basically followed the same physics, the same. Had the same sort of because as you asked, what was actually in the message, right? I'll quickly go through them. All the numbers that when we talk about numbers and things like that, it's all in binary code, and that's what's encoded into this picture. You can, if you go on the internet and have a look for it, the Arecibo message, and have a look at it, and you can see what we actually mean. First of all, there was the number 1 to 10 in binary numbers. The atomic numbers of hydrogen, carbon, nitrogen, oxygen, and phosphorus, which are the essential elements that make life, especially on Earth. So they were assuming that they would know what that meant. There was formulas for sugars and bases in nucleides of DNA. So what else do we have? And this is a fun bit. They had a very simple drawing of a double helix. Now, when I saw the drawing, I didn't know what it was. So very obscure. It was very. They'd have to be very, very intelligent to guess what that was. They also put in the number of nucleotides in DNA. And then there was a picture of a human being. Now, I all hope they play Minecraft. Because this human being,
Mr. Minecraft, wasn't it?
That's right. It was made out of blocks. It was made out of blocks.
Well, it was the 70s or 60s.
Exactly. So, and of course, ETs like us. Blah, blah, blah. They also put in the height of human beings. Well, I assume they took an average because they put in that we were all 5'9".
Oh, I'm above average then. Fantastic.
I'm underachieving, so I can walk straight under that bar without touching it. They also put in the number of the population of the people on Earth. And then, and this is another fun one, there was a pictorial diagram of the solar system, and it went from left to right, from the sun to sort of like Mercury, Venus, Earth, etc., all the way out.
And including Pluto, no doubt.
Yes, and that was you stole my thunder there.
Sorry.
But what they did is when you got to Earth, they actually raised it up. So it was out of the plane,
so that they can see where it's coming from.
And it was literally underneath. It was almost between the legs of the little man, the little block man, who was stood there. So just to give them an indication of that's where we were. But as you said, there were 9 planets. So that's right. So they're going to be confused that if they come here now and they look at our textbooks, they say, "Well, hang about, you said you had 9 planets. Now you've only got 8. What's going on?"
If you can't even be bothered to work out how many planets are in your own star system, we don't want to know you.
That's right. That's right. Yeah.
Well, that's fascinating, Daz. Thank you very much for that.
There's just a couple of other things.
A couple of other things, okay.
Yeah, just a couple. There was a diagram of the Arecibo dish with its diameter in binary code again. Yeah. And of course, it actually showed some lines on it that showed that it was actually a transmitting dish. And the only other thing I will say is the sending of that message caused a lot of controversy. But that's another story.
Why was it controversial?
Basically, when the Astronomer Royal at the time, Sir Martin Ryle, found out, he was very perturbed because he was basically, and not just him but others, were basically concerned about the fact that we were advertising that we are here. And the thing was, they were concerned about what the reaction of ET could be. Would they be benevolent, or would they come here and basically just wipe us out because they want our resources or whatever anything like that,
or just because they're nasty?
Yeah, exactly. Yeah. And like I said, they could they could eat other aliens, so they could be want to eat us and all that. We could be a side order of beings, human beings. So it caused a lot of controversy. Frank Drake was a bit dismissive of it, said, "Well, we've been leaking out radio signals and TV signals into space for decades. We've had no possibility of no reaction. Nothing's happened." But then again, that's a bit of a non-argument, because our signals really haven't traveled anywhere, because we've been doing it for such a short time and all that. And of course, we're also beginning to go silent as well, because we're going down the digital route.
Yes,
we're not producing so many things, and this is the same with why we haven't heard ET. They've probably gone beyond that.
Yeah, I mean, who knows? Who knows what technology they might have?
So that's my Arecibo message. So I hope you can now understand it. I could be shameless here and plug my show, because next week's show is all about the controversy. So tune in and listen to that. And
there you are.
That's shameless. Shameless.
Do catch Daz's astronomy show. What day of the week is it on, Daz?
It's usually the new series always starts on a Sunday night, but it's repeated throughout the week.
Right.
The same as your wonderful program that I listened to today.
Oh, did you enjoy it?
A Week in Space. That's Andy's show. So this is a love fest, isn't it?
It is, isn't it? Let's get a run. Okay, right. Let's move on. Right. Cool. So, my turn, I guess. A is for Al.
Al. Okay.
AL. Yes. Al as the prefix of a lot of names of the stars in the sky.
Oh, okay then, yeah.
For example, Aldebaran, Altair, Algon, Alpheratz. And this is quite interesting, because these are all Arabic names, and not many people know that our names for a lot of stars in the sky were, well, not necessarily first come up with by Arabs, but a lot of them are Arabic names. Of course, you've got a lot of Arabic names that don't begin with Al, like, for example, Arcab, which actually is Arabic for the Achilles tendon. And a lot of them don't actually begin with Al, but a lot of them do. Now, the ones that do begin with Al seem to go back to ancient Greeks, because what happened, it was the ancient Greeks who identified these stars. It was mainly Ptolemy that came up with his famous Almagest, which was a star catalogue, if you like, of just over 1,000 stars, 1,025 stars. And then the Arabs took those names and really, as you do when you're dealing with a language that isn't your own, you convert them into your own language. So we have Aldebaran, which means the follower, Altair, the flying eagle, Algol, which is an interesting one. That's head of the ghoul, believe it or not.
Oh, okay, then.
Yeah.
The ghoul.
And my personal favorite, I mean, there are lots of them. I just go through these four.
Yeah.
Alpharats, which is the navel of the mare. So, yeah. So what happened, there was a famous Muslim astronomer, one of the great 9 Muslim astronomers, and his name was Abd al-Rahman al-Sufi, and he lived between 903 and 986 AD.
Okay.
And he took Ptolemy's Almagest, expanded on it, added to it. And he was actually a very, very interesting guy. He was the first person to identify the Small Magellanic Cloud, believe it or not.
Oh, okay then. Oh.
Which, believe it or not, you think of it as being a Southern Hemisphere thing, visible in Australia. For our listeners who don't know, this is one of the small satellite galaxies that orbits the Milky Way. The small and the large Magellanic Clouds you can see very clearly in the sky with your naked eyes. You don't need a telescope, looking like clouds from the Southern Hemisphere, noted by James Cook, Marco Polo, among other explorers. But Abd al-Rahman al-Sufi was the first person to write about it, because it's actually visible from Yemen, where he was at the time and where he did a lot of his observing. He was actually Persian by birth. And the other thing he wrote about, he was also the first person to write about the Andromeda Galaxy, M31, which he described as, believe it or not, a small cloud. So all that's quite interesting. But what happened then was that the Arabic names came back to Europe in the Middle Ages, and the Europeans translated them into forms that they could write and pronounce. So a lot of so it's gone backwards and forwards a bit. So trying to establish the original names of these stars and why they were named as they are has become a bit of a problem. But I would guess there are at least 30 or 40 naked eye stars in the sky that have Arabic names, and most of them we can attribute to Ptolemy via Abd al-Rahman al-Sufi, via the European astronomers of the medieval times, pre-Renaissance.
Yeah, that's excellent.
That was it really, which I find all that quite interesting.
Yeah, because like you say, I did know that a lot of the stars are got Arabic names, as you said. You can usually pick them out. Yeah. But there was, if I remember right, I can't. No, I'm not going to go down that road because I can't remember exactly what it was. But there were four main stars I remember, and I can't remember any of them. But they all had Arabic names, and they had some sort of like mystical powers or something, and things like that. Yeah. But because is Algol one of them?
Algol is one of them. Algol, of course, is a famous variable star. That's
right. That's the one that you can map over. Within a few hours, you can map its dimming and its brightening.
Yeah, absolutely. Became
so that the eye of the as you said, the eye of the Gorgon. Yes, yeah.
Yes, absolutely. So
yeah, the winking eye, as they say.
That's right.
Yeah.
So I mean, a lot of this has been lost because we had, there were the original Arabic astronomers in the region before Mr. Al-Sufi. Yeah. And he would have taken their original names, maybe modified them, maybe kept them as they were. We don't know. But most of the basis of his work came from Ptolemy, the famous ancient Greek. So these names have been flying about a bit. And we
because you probably find a lot of the names have all been lost, as you said, in the past and things like that, or they've been, mutilated in their spellings and things like that. Right. So, I mean, the Persians and the Greeks and a lot of the ancient civilizations were well advanced in astronomy. They did,
absolutely
know and of course the only thing is they didn't have the technology that we've got, but they had the dark skies.
Yes, indeed.
So yes, so to be able to see Andromeda would have been more simpler in those days.
Oh, absolutely.
Because now you've got to find a really dark sky. I guess
it would have been quite a bright object in the sky.
Exactly, and because it would have been, like as you said, a cloud. It would have been a cigar-shaped smudge. I like some of the Arabic names, I must admit, because they just mix it up a little bit. It's better than sort of like the Greek alphabet, which we normally use. Absolutely. Which usually categorizes the brightness of the stars within.
I just think it's sad how so much of this has been lost, and there's been so much, if you like, Western chauvinism towards, Muslim astronomy, Islamic astronomy, and it's a real shame because they were, during what we call the Dark Ages, they were really
well
guardians of a lot of the science that had gone before. And not just astronomy, in engineering, of course, architecture. Because even in my village here, in Catalonia, we there's a lot of Arab inspired architecture. If you go to the south of Spain, everything's blue and white. Which comes across from North Africa.
Because that was the Moors' influence, wasn't it?
Absolutely. It's all Moorish and it's absolutely unbelievable what.
And it's all geometric patterns.
It's all mathematical as well.
Mathematical.
It's stunning what they did, and it's just a shame that it's not by ourselves obviously, but a lot of people it's looked down on, simply because it's Islamic, and that should not be the case. That should not
exactly. I mean, even India was another great civilization that was well versed in the stars and astronomy and things like that. So a lot of it, like you said, a lot of it's been lost. And it's a shame, as you said. So what really have we lost? So it does seem a bit.
I mean, obviously things get lost in history, but I think it's a tragedy that things get lost simply because of where they came from.
Exactly. As you said, it's prejudices and.
It's not a lack of recording or documentation. It's simply because of prejudice, and I think that's a tragedy. Anyway, that's that. So over to you again. A is for
Andromeda.
Talking of which.
As we know, Andromeda is a constellation in the sky.
Yes.
But hidden inside Andromeda is the Andromeda Galaxy, from which it gets its name, which is M31. Now, probably, like as I said before, a lot of people have probably seen it if they've been lucky enough to get dark skies and all that. It would have been a spindle-shaped blob in the night sky, but they probably didn't realize, what they were actually looking at. But a lot of people have probably seen it without actually realizing it. But now, what I'm going to sort of like talk about is, as we know, the Andromeda is one of our the galaxies in our local group, including the large and the small Magellanic Clouds that you mentioned earlier on, plus a few others. Now, in our local group, that means we're all gravitationally bound together, and we all mix ourselves up. And as most people know, Andromeda and the Milky Way are moving towards each other. And of course, in about 4 billion years, we're supposed to have an interaction.
About the time the sun starts to go red giant.
Yeah, exactly. So it's going to be a fun time if we're still around. I've marked a date in my diary.
Yeah, me too. I've got it in Google Calendar.
Yeah, so you get a notification. So absolutely. Here it comes. It would be nice to be around to be able to see an Andromeda, feel the sky. We are going to have an interaction with the large Magellanic Cloud before that. But as I said, I don't like the word when they say collision, because it sounds like two cars going head on into each other.
No, it's definitely not that.
Which is not. I mean, when you think about the space between all the stars in our galaxy, in our galaxy, in the Milky Way galaxy, and it's the same in Andromeda. That we're going to just basically pass each other by. There is going to be some interaction. There's going to be some star forming, which could be quite spectacular. All this gas getting mixed up and kicking off stars and all that. But for anything to actually collide, it's going to be very, very unlucky. For anything to be
it will be very much like two clouds coming together. They'll pass through each other. There'd be a bit of interaction between the water molecules because of gravity, but you don't hear loud bangs in the sky when two clouds come together. So it's definitely not a collision.
So
the other thing that it's going to do, of course, it could well throw a lot of stars out of either or both galaxies altogether.
That's right. Yeah, there's some stars are going to be thrown off. Yeah, I mean, it's going to completely mess up the spiral rings of both of the galaxies and all that. And so some stars, our galaxy, we could be thrown out our solar system and we could just drift off into space, but we'll still be a solar system.
Yeah. But we'll have better plots than Space 1999.
Yeah, exactly. But we'll have the eagle. That's what we want. So yeah,
we won't have that inexhaustible supply of eagles.
No, exactly. Yeah, they blow one or two up every and episode.
They've still got enough.
But what I wanted to talk about is that, as I said, it's 4 billion years when we're supposed to have this interaction, but people don't realize the interaction has already started.
It has,
because the galaxies are surrounded by what are called halos. Now, these are regions of gas and fine dust particles and all that. They are diffuse and nearly invisible. We can hardly see them, but they surround all the galaxies. We can't study ours because we are actually inside it. Yeah. So we can't actually look at it. But with the Andromeda coming towards us, it's our closest galaxy. They've been able to measure its halo, and it's massive.
Yes.
And basically, these halos are basically, they're called circumgalactic mediums. So they're CGMs, as they call them.
Right.
So it's circumgalactic mediums. Make a note of that because there will be a quiz.
I've written that down. Okay,
that's brilliant.
Yeah.
But so how they've studied these is they used basically the Hubble telescope, and they were using, if I remember rightly, it was ultraviolet light, and of course, with ultraviolet light coming through the atmosphere, disappears. It gets wiped out. It gets absorbed.
Yes.
So they've had to use the Hubble telescope, and what they did is they used quasars behind Andromeda.
Right.
And what they were looking at was using the light from these quasars, which are, of course, are overactive black holes that have gone stupid. They're gone, they're they're fastly feeding, and they're very bright, but they're very, very far away.
Yeah.
So what they did is they looked at the light coming from these quasars, and basically they noted the change in what was being absorbed and things like that, so they could actually see the halo by looking at all these stars.
And our galaxy presumably has a halo as well.
Exactly. And what they found is that this halo that surrounds Andromeda is absolutely huge. So they, like I said, they used the Hubble Space Telescope, and they were able to use up to, because it's so far away, but close enough, they were able to pick out 40 lines of sight to these quasars.
Wow.
And by using that, then looking out, they could see that the light was interacting with these halos. Now, these halos, they're in two parts. There's an inner halo and there's an outer halo. Right. Now, the inner halo is hotter. It's more dynamic. is interacting with things, and they think this is where the sort of like the star. This is what kicks off stars and supernovas and things like that. And then the outer halo, which is far smoother, as they call it. It's more even. It's not moving so fast. It's not doing anything special.
Right.
It's just sitting there, and it's basically just holding. It's gravitationally bound to Andromeda. But as I said, these two halos are now actually bumping up to each other. So the interaction between the two galaxies has actually started. Wow. So it's no need for a hard hat or anything like that, because it's still going to be 4 million years before 4 billion years before this all kicks off.
So what are these halos actually made of, Daz?
Most of it is gas. Some of it
thin, tenuous gas, I would imagine.
It's very fast moving gas. Like I said, in the inner halo. Let me just see what I can find. I'll just have a quick look. It says the inner halo is very dynamic, and that points to supernovae, because also they found that the inner halo is also very heavy in the heavier elements. So they've been seeded with gas and material from supernovae. So that's the which of course once they blow up, they expel all their elements and all the produce of their lifetime's work into these halos. Right. So yes, it was ultraviolet light that they used, and using these quasars, they were able to, like I say, observe these halos and measure how wide it is.
So the Milky Way and M31, if you like, have had their first kiss.
Yeah, literally, they've had their first kiss, their little bump, and it. I forgot what I was going to say now.
Well, while you're thinking, another thing about the merging of the two galaxies. Two things. A lot of people think they'll just merge and that'll be it, but in fact, each galaxy will make several passes through each other over the course of millions of years. So there'll be an initial, I'm not going to say collision, an initial encounter. And then gravity will tear them apart again because of their velocity, and they'll shoot off outside each other. Gravity will then bring them back together, and that will repeat several times, X number of times, before finally gravity wins, and they come together and they form one of the giant elliptical galaxies that we see everywhere in the universe, which are, when you see an elliptical galaxy, which is literally, it's in the form of an ellipse, you can't make out any stars in it. It's a remnant of a galactic collision, and extremely ancient at that usually. So, this whole process of the two galaxies coming together will take place over many millions of years. It's not like it's going to happen overnight. If you look out, I think it's ESA, the European Space Agency, who use the Hubble telescope. They have imaged lots of interacting galaxies. Yeah, galaxies some of those images are amazing.
Yeah, with usually they've got an ARP designation.
Yes,
and some of them are so fantastic. They're beautiful. And they form all these shapes, and you can see one of the best ones, of course, is the pinwheel. What's it called?
Yes.
Yeah, the one that was on the Van Gogh.
Absolutely.
M51?
M51?
Yeah. It's you've got the large galaxy, and then you've got the smaller galaxy, which is actually rotating around it, and it is actually behind or beyond the bigger galaxy, but there is a star bridge and an interaction going on between them.
And some of them have been given great names, like you have the mice, for example. The antennae galaxies, which is another one.
That's right. That's
named after what they
tendrils.
represent. That's right. And when we look out in the universe, we do see all of these galactic mergers in various stages of completion, if you like.
That's right. Yeah,
so they do form all sorts of shapes. And, you know, I'm just a bit sad that I am not going to be alive to see the Andromeda Galaxy looming in our skies.
Large in the sky, yeah.
I mean, that would be good. And another thing about the Andromeda Galaxy, while we're on the subject, is that for a very long time, in fact, probably for over 100 years, it was thought that the Andromeda Galaxy was much bigger than the Milky Way, but recent studies have shown that it's about the same size, although it does have more stars. So
I mean, people make the mistake of saying that the Andromeda is moving towards us, but it's not that really. We're moving towards each other because
we're moving towards our mutual center of gravity.
Yeah, that's right. So it's
jolly good. Well, thank you for that.
That's all right. That's fine.
A is for Arthur C. Clarke. Because Arthur C. Clarke was one of the big three of science fiction writers, the other two being Robert Heinlein and Isaac Asimov, another A. And he was an extremely interesting guy. Firstly, I mean, he's known for his science fiction work, including, of course, the book of 2001: A Space Odyssey, which he wrote as they were filming the film. But in the Second World War, Arthur C. Clarke worked on radar. Now, when you think of somebody working on radar, you think of the type of radar that's going to spot enemy planes. That's not the type of radar he worked on. He worked on ground approach radar. Planes using radar for ground approach. And he did a lot of work on that. So the landing systems that virtually all modern airliners use to land using radar, especially at night and in fog and things like that, we can thank Arthur C. Clarke for a lot of the work he did on that. Also, he moved to Sri Lanka and in the 70s and took up scuba diving. And he'd been scuba diving for less than a month when he discovered an ancient temple under the sea off Sri Lanka, which nobody knew was there. So, you know, what a fascinating life he had. And he was, of course, the inventor of geosynchronous satellites. He came up with the idea of geosynchronous communication satellites, without which much of our modern broadcasting just wouldn't work. When Kubrick was looking for somebody to write or work with him on 2001: A Space Odyssey, in my opinion, the greatest film of all time, of any genre, somebody suggested Arthur C. Clarke to him. And Kubrick thought that Arthur C. Clarke was, quote, some nut who lives in a tree. And true story.
Okay.
And he took a lot of convincing that Arthur C. Clarke was the man for the job. They met up in a hotel in New York. And Kubrick, from the first meeting, they both took a shine to each other and realized that they could really work together and do great things.
Yeah, and because a lot of his writings were quite prophetic, weren't they?
Absolutely. But he was one of the so-called hard science fiction writers. That is, his writings were based on what could actually happen given the physical laws of the universe, rather than, you know, kiddies' fantasies like, you know, Star Trek and Star Wars nonsense. But this was real science fiction. You know, it was science in fiction. But in later life, he veered slightly from that. And you may remember a TV series he did, or he did several series of it, called Arthur C. Clarke's Mysterious World, where he looked in not exactly the paranormal, but veering that way. And he started towards the end of his life believing that things like telepathy might actually exist. So he veered away from the hard science towards the end of his life, as is, you know, that's fine. If that's what he wanted to believe, that's fine. But he was a big embracer of things like email and the internet, immediately saw the potential of those because he'd predicted things like that in his books, and he knew how they worked, you know, and he knew their potential. So he was using email and internet long before a lot of people were. And, you know, sending his books and manuscripts and whatever over the internet, chatting with people all over the world. And you know, what a great loss to writing, because his vision in The Sentinel, which was the short story from which, you know, they took the idea of the film of 2001. that mankind goes to the moon and discovers an alien artifact. And of course, all of the philosophical questions that come with that, because that was the thing about Clarke's writing, that he did have a sense of greater things, not religiously per se, but things beyond our understanding, and immensely powerful things beyond our understanding that perhaps humans will never understand. And that theme you can read if you read Rendezvous with Rama or Childhood End, or any of his classic novels. That really does come through. And he was, if you can compare him with Asimov, I'd say that Asimov was much more technical writer because he was an actual scientist.
Yeah.
He didn't have this grand sense of proportion. If you look at something like 2001, it was described by somebody at the time as the world's first multi-million-dollar religious movie. And because you have got that sense of a greater something beyond humans, call it God or nature, or, whatever you want to call it, something bigger than ourselves. And that, I think, was one of the great triumphs of 2001, because you never actually saw this greater thing. You never saw the aliens. You didn't, unless you were paying very close attention when the film came out. You probably didn't know what the hell was going on anyway. But you did get this immense power in the film, mainly because I think it was a visual film. There was very little, the first words in 2001 aren't spoken till nearly half an hour into the film.
Yeah, and it starts with primitive man, doesn't it?
It does. And there was that great sense of perhaps destiny, a greater power, people evolving into a new species, and things like this. And all of those ideas run through Clarke's novels, which is why I think when I was growing up, I just absolutely loved them, because he had this immense sense of scale that comes across in films like 2001. The sequel, 2010, did a creditable job, but the book wasn't as good as 2001, and so the film really couldn't be. But although I still maintain it's a great movie, it got very mixed reviews when it came out. But
I'm going to be controversial here.
Go on.
I've never seen it.
You've never seen 2001?
I've never seen 2001.
You must be joking.
So, no.
Have you gone out of your way not to see it?
Well, the thing is, I've seen clips of it and things like that, and I thought, that's not my type of film. But like I say, I've only seen snippets. But everybody says it's, like you say, it's deep, it's philosophical, and stuff like that. So I really must make an effort to fish it out and have a look at it. And
you must. One thing you must understand before you watch it, Daz, and I'm absolutely shocked because I'm sure the listeners are, that you've never seen 2001.
I know.
One
I'm
thing
shocked.
that you must understand: it's a very slow film.
Yeah.
Kubrick took his time because he had a story to tell that he was not going to rush.
Yeah.
Arthur C. Clarke, during the first screening, which was in New York, if I remember correctly, he left the theatre in tears. He'd never seen the film. It was the first time he'd seen it. Kubrick had included a sequence that lasted 36 minutes of an astronaut jogging in a spaceship and nothing else. No dialogue, just an astronaut jogging in the spaceship, in the Discovery spaceship, simply to show what the tedium of long-term spaceflight would be like. And Clarke was literally in tears, thinking he's ruined it. Luckily for the final release, Clarke convinced him to take it out. So you won't have to suffer that.
I was going to say, that would definitely. I mean, the thing is, my philosophical films and all that about what's beyond the stars and all that is something like Transformers or something.
Right. Well, listen. By the time we record the next program, your mission is to watch a Blu-ray copy of, because you have to see it, because it is an unbelievably incredible visual film. You have to watch it. That is your mission for this week.
Yeah, I'll keep meaning to
and come back next week and tell us how you got on.
Yeah, if I'm awake. Yes.
Oh, yeah, you'll be awake. You'll be curious.
Yeah,
You'll be curious to see what happens next, because it's a fantastic story.
Right, my next A is only going to be a quick, short one, and it's arsenic.
Arsenic?
Yeah, and it goes back to atmospheres and things like that. And basically, it's research has been done, and it's, as we know, in the early evolution of the Earth and all that, oxygen didn't exist. But organisms did. And so people have often wondered, what were they using, other than, because oxygen didn't exist, what were they using?
Right.
And basically, so 1 billion years ago, long before oxygen was readily available, the notorious poison arsenic could have been the compound that breathed new life into the planet. In Chile's Atacama Desert, in a place called Laguna La Brava, scientists have been studying a purple ribbon of photosynthetic microbes living in a hypersaline lake that's permanently oxygen-free. This is the only system on Earth where we could find a microbial mat that worked absolutely in the absence of oxygen.
Wow.
Microbial mats which fossilize into stromatolites. Remember those on Mars?
I do remember the alleged stromatolites on Mars.
Yes, which
the
which could be interesting. Yeah, of course they are. Have been abundant on Earth for at least 3.5 billion years, and yet for the first billion years of their existence, there was no oxygen for photosynthesis.
So they must have been using something.
Something else, that's exactly. How these life forms survived in such extreme conditions is still unknown. By examining stromatolites and extremophiles that live today, our little water bears and things like that, researchers have figured out a handful of possibilities. While iron, sulfur, and hydrogen have long been proposed as possible replacements for oxygen, it wasn't until the discovery of arsenotrophy in California's hypersaline Searles Lake and Mono Lake that arsenic also became a contender.
Now, Mono Lake is quite interesting. Just a little fun fact for you. That is the lake that the diver on the cover of Pink Floyd's Wish You Were Here is diving into.
Oh, is it?
Yeah.
Okay.
That's Mono Lake. Do you know the image of the legs up in the air?
Yeah, exactly, yeah.
Well, he didn't actually dive into it because otherwise there would have been a splash. And if you look at the water, there's no splash. He was actually doing a handstand on a chair that was under the water. And his legs were sticking up above it. It looked like he'd dived in. But, of course, there's no splash in the water, so it wasn't. I think that was part of their, mystique, to come up with these mysterious images that were impossible. A man diving into a lake, but no splash. But anyway, yes, Mono Lake is well known for it's an extremely primitive lake as well.
Yeah, exactly. This is exactly it. And it says, since then, stromatolites from the Tumbiana Formation in Western Australia have revealed that trapping light and arsenic was once a valid mode of photosynthesis.
That's amazing.
In the Precambrian, yeah.
That is amazing.
The same couldn't be said of iron or sulfur. So it says even the La Brava life forms closely resemble a purple sulfur bacterium called, oh no, look at this. Ectotheora.
We'll get back to you later, listeners.
Yeah. I'll practice that. Yeah, can you spell it, Andy? Anyway, no. And it says, which was recently found in an arsenic-rich lake in Nevada, and which appears to photosynthesize by oxidizing the compound arsenite into a different form, arsenate. While more research is required, La Brava microbes also metabolize arsenite. Initial research found the rushing water surrounding these mats is heavily laden with hydrogen sulfide and arsenic. So it does look as though other compounds could be used to basically help life along.
I wish I were a chemist and I could understand how all this relates to each other.
Exactly, because we know that in photosynthesis that oxidization Oxygen produces oxygen and things like that, and it needs oxygen to do the photosynthesis. But then to actually then be able to, because the oxygen isn't available, they can then change or evolve to use something else. Basically means that we may have to change our ideas of what we're looking for when we're looking for extraterrestrial life and all that. So all these hostile planets that we think possibly couldn't harbor life because of their atmospheres could have some sort of microbial life there.
Amazing.
So so it's probably a bit arsenic's probably just more than a poison.
Right.
So,
Right. So thank you for that. My last one is a very short one. A is for Atlas.
Okay.
Not the venerable rocket that's been used by America for 50 years, I guess. Atlas. This Atlas is one of the inner moons of Saturn.
Oh, okay.
And the reason this is amazing is because it's shaped like a UFO.
Yeah.
Or, if you prefer, it looks like two fried eggs back to back.
Yeah.
So it has a sort of a roughly, it's not even spherical, but it's a sort of an elliptical core. But around its equator, it's got this enormous ridge sticking out of it that makes it look for all the world like a UFO. And the reason for this, they think, is that it orbits just outside Saturn's rings. Just inside Saturn's rings. And it's meant to be, or they think it is, the effect of dust from the rings falling onto the equator of this object because of gravity. That's where it gets pulled to. And over the eons has built up a solid ridge around the equator that makes it resemble a flying saucer, which is quite amazing. It's not the only one that looks like that orbiting Saturn. There's another moon of Saturn called Pan. And Pan is another one that has an equatorial ridge, although in comparison to the size of it, it's much smaller. If Atlas looks like two fried eggs back to back, Pan looks more like a ravioli. So you've got some appetizers circling Saturn there. But we're talking about extremely ancient accretion of dust onto these little moons. And I just thought that was interesting. The first time I saw a photo of Atlas and Pan, I thought, come on, somebody's pulling my leg. Is it April the 1st? But these are genuine. And if you see them from a distance, they do resemble UFOs for all the world. And I don't think any planetary scientist would have expected that. Who ordered that, for goodness sake? That's amazing.
Exactly, because in fact this is a good job, because I did moons beginning with A in the solar system as well. So so I knew Atlas and all
Great
that.
minds think
and the one that I was really interested in was Ariel.
Oh right, Uranus.
Which is Uranus, is because there's some very interesting features on there, and it's also shown signs of cryovolcanism on there.
Isn't Ariel, if I remember right, isn't Ariel got lots of very light coloured ridges across it?
That's right. It's covered in what look like what we would call on the moon like rills.
Yeah, like rills.
Collapse things and all that, and there's lots of fractures around them. And this is from where these eruptions of they think it's ammonia ice that has been squeezed out of the water ice because of the cold temperatures and stuff, the way it reacts at those sort of like temperatures. I think it's minus 97 degrees C.
Oh, balmy.
So
Positively
it's shorts weather but they've noticed these cryomagnas in impact craters and things like that, and it's so they know it's active, yes, it's they think it's they don't think it's from internal heating as such, or it could be tidal stresses being caused by Uranus, and of course Uranus is very strange in its own right, so I know it's your favourite planet.
It's not strange at all. It's just boring. So yeah.
But
I guess Uranus is an exceptionally interesting world.
I mean, there's quite a few moons beginning with A.
Yeah, there are.
All doing their own little different thing.
Yeah.
You got some, but one of the strangest ones, if I can just find it, if you just bear with me a second, was it's not actually a moon as such. It's what they call it, Antiope.
Oh, Antiope.
Yeah, that's it, Antiope. Yeah. Which is a trans-Neptunian body.
That's right.
And it's a bit of a strange one. But it comes under A. At first, it was discovered in 1866 and thought to be just a bog standard asteroid. And it was unremarkable until the year 2000, when it began to reveal itself as being two separate objects in sort of like a binary asteroid system.
Oh, really?
And both objects are in synchronous rotation and orbiting their common center of mass, or barycenter.
Yeah, I know him well.
Barry. Period of 6.5 hours. But being indistinguishable in size or mass, each can be regarded as a moon of each other. So you've got basically a binary moon system.
So who's mooning who?
Exactly. Yeah.
Wow, that's
there was a binary moon system, and that was
I never realised Antiope was a binary. Thank you for that, Daz. I never knew that. I shall have to look that up. Okay, Daz. So my turn now, and my next A is A for Anthony Wesley.
Oh, okay then. Who's Mr. Anthony Wesley?
Well, it's funny you should ask that. Anthony Wesley, born in 1965, is an Australian amateur astronomer. Now, you might think, why? Well, he has made two remarkable discoveries. Just goes to show with amateur astronomy that some people have all the luck. In 2009, almost exactly 15 years after the impact of Comet Shoemaker-Levy 9 into Jupiter, he discovered that near Jupiter's south pole, there was a visible scar in the atmosphere because there had been a big impact there. And this scar was the size of the Pacific Ocean, would you believe?
Oh, not a small one then.
No, quite a large one. And he became quite famous for finding that. But then the very next year, he was visiting a friend and he was using a 15-inch telescope to look at Jupiter, and just happened to catch a flash lasting for about 2 seconds in the atmosphere of Jupiter. Something was burning up in the atmosphere, and it was believed to be an asteroid. And in fact, it was the first time that an impact on another planet had actually been seen live, as it were.
Oh, excellent.
Yeah. Oh. Now, this was significant because after Comet Shoemaker-Levy 9 crashed into Jupiter, astronomers really believed that Jupiter would not suffer another major collision for several hundred years. So to find two years running sizable objects crashing into Jupiter is quite significant, because it means Jupiter obviously attracts, if you like, large, inverted commas, large objects much more frequently than we thought. And this goes along with the whole idea that Jupiter has been acting as, if you like, a vacuum cleaner throughout the history of the solar system, hoovering up objects which otherwise might have struck planets like the Earth.
Like the Earth,
so Mr. Wesley, if you're listening, fantastic discoveries, sir, and of quite some significance for those people who study planetary impacts.
Exactly. I mean, that's fantastic. As you said, it's probably, if it's luck or what, it's a fantastic discovery. And if I was wearing a hat, I'll take it off to him. Absolutely fantastic. That's brilliant.
Yeah. So there we are. That's my next A. What about yours? What's your next A? A is for
right. A is for albedo.
Albedo. Great.
Albedo, yes. Really, the question is, how does the moon shine at night? Well, really, the moon, as you know, doesn't shine at night. It does not create or emit its own light. It's not a star.
No.
The light we see is actually light from the sun hitting the moon and then being reflected back to us.
Yeah.
And as we know, all objects absorb and reflect light. And this can be measured, and it is known as an object's albedo. That's ALBEDO.
I was somebody's name, Mr. Albedo.
Mr. Albedo, yeah. Well, you own corner shop round our way, actually. When we look at the moon, so of course, as we know, the dark areas and the light areas of the moon's surface have different albedo ratings, and that is why we see the contrast. In fact, the overall albedo rating for the moon, now this is an albedo rating, is 0.12, which means it reflects back 12% of all the light that falls on it. So we're seeing 12% of the light that's actually hit the surface of the moon.
Only 12%?
But it does.
Wow.
Sorry, mate.
So only 12%. So that must be.
Yes, only 12%, which is really surprising because when you look at the moon through binoculars, telescopes, and all that,
it's very
bright. A moon filter, because it just takes that edge off because it does.
It can really dazzle your eyes through a telescope.
Exactly, it ruins your night vision.
Absolutely.
So, like I said, it seems brighter than that. But what basically, just to put it in perspective, the Earth has an albedo as well, but the albedo for the Earth is 0.30, so reflects 30% of all the light. Can you see a pattern going on here? 0.12 for 12% and so on. Yeah. It takes approximately 8 minutes and a quarter seconds for the light from the sun to hit the moon and then reflect back to our eye. Now, Andy, ask me, what is Earthshine?
Daz?
Yeah?
What is Earthshine?
I'm glad you asked me that. People ask what Earthshine is in respect to the moon, and that is where the sunlight, now get your thinking caps on a little bit, the light from a crescent moon, as I said, it's the sunlight hitting the crescent moon or the partial moon, coming back, hitting us.
Yeah.
And then with the Earth's albedo being 30%, so it's greater, there's 30% of that light that we've received from the moon is then reflected back to the moon. And it's just enough to light the dark portion of the moon.
And in fact, in rural areas of England, that is known as the new moon in the old moon's arms.
That's correct. That is absolutely right. It's quite poetic, really. It is.
It's beautiful.
So what you got to remember, basically, it's the Earth's 30% reflected back, and you can actually see the dark portion of the moon, the portion that the actual Earth is getting in the way of on the. I'm thinking of something else there. I'm thinking of an eclipse. Forget that. But so basically, what you've got the light from the sun hitting the moon, coming back to us, then it's reflected back to the moon again.
Nice bit of ping pong.
Yeah, a bit of ping pong going on there. So basically, all the planets have an albedo. That's why we actually see them.
Well, I'm guessing that the high albedo of the Earth will be due to the cloud cover. So yeah. So with a planet like with Venus, which is total cloud, what's the albedo of Venus? Just
now you're asking. I was just thinking of the moon and the Earth. You throw these things at me.
You might have a list in front of you.
No. Lists? I don't do lists. No, yes, because but also it's not just the clouds, because again, like you say, they're very reflective. But also you've got the waters, the oceans, and things like that, so which are like mirrors. But basically, it'll be fun exercise for people to work out how long it takes for the albedo effect from the different planets, from the different distances. Of course, that will vary according to where they are in their orbits.
Yeah.
Because remember, none of the orbits are actually round; they're elliptical.
Absolutely.
So, so basically, that's mine. The albedo, and its reflection of the sun's light onto the Earth, and that gives us our moon.
Interesting stuff indeed. Well done.
Certainly.
Right. Well, there we are. My next A. A is for averted vision. Now, here's a question for you, Daz. When light enters your eye, where exactly does it focus if you've got good vision?
That's a good question. I would assume it can't focus right on the center of the eye, because that's where the optic nerve comes in.
Well, this was going to be my point. That
sorry.
It wasn't a trick question, Daz.
Yes.
No, you see, right in the center of the retina is where the light focuses. Yeah.
Yeah.
Right in the center of the retina is where the optic nerve joins the eye, and that is not light sensitive. And do you know the technical name for that point, Daz?
I have heard it, but I couldn't tell you what.
It's called the fovea. Fovea. It's that point right at the back of your eye, right in the middle of the eye, where light focuses. Of course, if you've got vision problems like short-sightedness or long-sightedness, it focuses in front of the retina. But if you've got, if your eyes are working as they should, light actually focuses on the point that isn't light sensitive. Now, this means that when you look through a telescope, because images, we're not talking about a dazzling moon images, but other images of, say, a galaxy or a nebula or something, or even a planet, they're not bright images. So the amount of area that light is falling on at the back of your eye, you don't get many photons. And because your optic nerve is sitting right in the path of the light, you can't really see very much. But you find that if you look slightly to the side of the object, you can actually see it as much brighter. Now, of course, it's very strange, because if you look at something directly with your eye, you can see it. But if you look slightly to one side, although the image might appear brighter in the telescope, it's not, you can't really look at it directly, if you see what I mean.
Yeah.
But it definitely appears brighter, because you are forcing the light to fall not on the center of your eye, but a point to one side. And casting your eye slightly to one side in a telescope will enable you to see detail that you otherwise couldn't. And this is known as averted vision. But of course, it's also another good reason why intelligent design is a load of nonsense. Because if there is a God who designed the human body, why the hell did he put the optic nerve at the point at the back of the eye where light focuses? It makes absolutely no sense at all. So there we are, averted vision, a well-known tool that astronomers use to see things in telescopes that are dim, just to see a bit more light. Put your eyes just slightly to one side, look slightly to one side of the object, and you'll be able to see a lot more.
Yeah, because also when you do that, you also get to see a bit more color as well.
Yes, that's
because
right.
Again, for exactly the same reason. So
exactly the same. Yeah,
it's that's a good one actually, because that really explains why people, when they look at things, they say, "Well, I can't see any detail." But then, like you say, if you just ask them just to move slightly off center, that's it. They're away. Yeah, that's a great one, Andy. Actually, I like that.
There we are. Yeah. Okay. Over to you then. A is for
the Apennines Mountains. Apennines Mountains. Now they're basically. Do you know where they are? That's APENNINUS.
No. Let me have a guess. Venus?
No. You're close. The other side. Well, that's not that. Actually, no, that's too far away. It's actually on the moon. So I'm back on the moon.
You're not talking about the Apennines here.
Apennine. Well, the spelling I've got here is the Apennines Mountains.
No, it's not the same. It's not the same.
Yeah, they are named after the Apennines on Earth, and basically they're a range of mountains on the north part of the moon's near side. They are named after the Apennine Mountains in Italy, with their formation dating back to 3.9 billion years ago. Sorry,
old mountain.
And so that they're still, pretty. And basically, what it is the crater. As we know, when the moon formed, for a long time after its formation, it was bombarded with lots of rocks and meteorites and things like that flying through space. It was a bit of a shooting gallery going on. And what happened is the moon was still molten in its core. And every time a big meteorite hit, it would go through the crust. It would cause a big crater, and then what would happen is the magma would flow up into the craters and fill the craters, and any gaps in the walls, it would flow out. Now, these are usually the dark areas, so they're the newer part of the crust, and we call them mare. And basically, I'll call them the Apennines, just to make it easier for us. It's on the edge of Mare Imbrium. Mare Vaporum, and Mare Serenitas. Right. So, and they form an arc which goes from west, curving up towards the north. And they also contain Hadley's Rill.
Yes, I remember Hadley Rill.
That's right. It was visited by the Apollo chaps in their little buggy. And basically, Mons Hadley, which is actually one of the mountains in the range, is considered to be the highest mountain on the moon. But it's not the highest point. Yes, it's the highest mountain, but it's not the highest point on the moon. Right. Which beggars, description and all that. But as I said, it was visited. Apollo 15 landed near to the Apennine Mountains. And as I said, they visited Hadley's Rill, which is a valley, a deep valley, collapsed sort of like tunnel, lava tunnel. But so that's basically it. They range, they rise as high as 5 kilometers, which is 3.1 miles high above the surface. So they're quite big mountains and things like that. And they're surrounded by sort of like rugged foothills and things like that. But it's like I said, this range, they stretch for a total of 600 kilometers, which is 370 miles. And it's a curvature, but it is actually the edge of the crater that formed Mare Imbrium. So that's it. That's mine.
Fantastic. Oh, that was very interesting. Though. Yes, I've seen the lunar Apennines when they're fantastic when you see the Terminator near them.
Yeah.
When the Terminator being the dividing line between night and day on the moon, and as it moves across those mountains, it's an incredible sight. So beautiful. So there we are. Right. Well, with that, listeners, that brings us to the end of today's program. We hope you've enjoyed it, don't we, Daz?
Yes, I certainly have. I've certainly learned a few things today.
Yeah, me too. It's been fascinating.
Encouraged me to actually go and have a look at some of these things. I'll listen back to the show because we've learned so much.
Yeah,
and listened to so much that there's a few things I want to chase up on there.
Yeah,
especially the Australian guy.
Yes, interesting, eh? Very interesting. Yeah. So Daz and I will be back next week. Next week, of course, logically, it's the letter B. So we'll be discussing anything to do with the universe beginning with the letter B next week. Don't forget, Daz, that before next week, you've got to watch 2001: A Space Odyssey. and come back and tell us what you thought.
Yes, the big reveal, wasn't it? Oh, shock horror probe.
Yeah. So that's your homework for this week. You've got to watch 2001: A Space Odyssey, because you must be one of the few people in the Western world who hasn't seen 2001: A Space Odyssey. Have you seen The Sound of Music, Daz?
Unfortunately, yes.
Oh, you have.
My parents used, it was, but
I think there was.
I could probably even sing you a couple of the songs, but I'm not going to.
Oh, go on.
No. I think a female deer.
Yeah, you're quite right. You shouldn't. I think there was a lady in the Guinness Book of Records who had seen it something like 170 times.
Oh dear me, that's probably after life.
That's going some.